Okay, thank you. So I do want to say I appreciate being able to be here. The talks have been outstanding. The sidebars have been even better. And my talk here is to not go into technical deep dive, but I'll be glad to do those discussions afterwards or in sidebars later. I do work at Georgia Tech and wear several hats, have to have multiple hats there, but I work for a group called the Georgia Tech Research Institute, which is full-time applied research. We operate like a not-for-profit consulting company. And I also created an IoT center at Georgia Tech, and that's what you see there. In fact, some of you, has anybody heard of Sedate? So I would like for you to take a look at that. Go to the website. We have the lead of that is a very expressive Frenchman who is a Georgia Tech person, and so he created Sedate. I'm the chairman of the board for that, and I'll talk briefly on that bit of information. Uh-oh, what'd I do? How do you forward? Sorry. Okay. Well, so I'm an engineer, but I get my daughter to help me with the applications on my cell phone, believe it or not. But I do want to have a few acknowledgments. So this is going to be a series of 2 or 3 different explanations of things that I think will be of interest, and it's specifically focused on where the DoD and the federal government is headed with the combination of IoT and 5G. As a result, you're going to see a mixture of slides. And the reason for that is because I had approvals to do those sets of slides, and I didn't want to modify them because that may change the approvals. So my background. So you will see those are various programs. I'm a high-speed network mobile systems person, a lot of last-mile technologies, underserved areas, but the bulk of my work has been for the U.S. government and for the DoD. And those are various tests. So you'll see the upper right, yes, it does snow in Atlanta, and if you've seen images, then it's legendary when we do have a snowstorm in terms of the traffic. But those are various tests at the Pueblo Indian Nation that we did for bringing technology to an underserved area. And then those are other tests that we've run out in Montana. So the goal there in some of these programs was wireless is ubiquitous. It has all kinds of different capabilities. How do you apply it in the right way? So we created a number of areas to do that, and that includes our Internet of Things Center, as well as some of the background work I do with smart cities with the City of Atlanta. And then something I really want to make sure that you're aware of is, again, the federal government's role that I sit on an executive committee called the National Spectrum Consortium. So Sedate, that's our Internet of Things Center. The key there is to focus on several objectives around educating the people. It's doing standardization and research, and it's a consortium of companies. A couple of the companies that are here today are actually members of that consortium, and the whole ultimate goal is to drive thought leadership. How do you do thought leadership around IoT? Just a quick snapshot of some of the companies that have been members. Not all of them are current members, but as you can see, it's quite a few. Each one of those, just like you out there, have a whole lot of interest in terms of what IoT can do for the industry and the industry as a whole. I have whole presentations on this that I do mostly for the federal government, but as you know, there's a tremendous amount of hype out there for IoT and now for 5G, where I try to cut through some of that because what's going to be the return on investment? How are people going to see their ROI? What does it really mean to a city that they can collect data they've never seen before, but now they don't know what to do with it? So those are some of the things that we help do under our program. And I won't go through the whole Sedate slide. This is just one example. We created 3 stages of the Internet of Things, just like you might expect. The whole set of monitoring and control. Once you do that, how do you do the data optimization? There's a half a dozen different types of approaches and tools to try to make that happen. Each one of our companies that are members are doing parts of that. We take some of the funding from the consortium and actually fund research programs at Georgia Tech, so it's a collaborative where a researcher from the company is working with, say, a professor and some grad students. And so that allows them to, again, create the thought leadership. And then ultimately, it's the interconnection of the intelligent things. So the data is pointless if you can't do anything with it. So I'll step away from sedate, but I welcome you to take a look at that. But I always had to include a couple of jokes for some of our DoD friends. Y'all may have seen that one. But this is an example of how targeted data is now getting out to people, and sometimes it's not structured well enough for you to even understand what's happening. And another key point is even the world's soothsayers and great business leaders actually wind up quite changing their opinion on different technologies and topics. So if a Larry Ellison, who has more money than I'll ever have, but if he thinks that, say, cloud computing is nonsensical, and then 4 years later he's singing its praises, then how do we pull something that really is the impact of an IoT, tie it together with 5G, tie it together with analytics, and do tremendous amounts of work for industry, for people, et cetera. These are some of the slides we could delve into, but they're topics that I'm quite sure that you're very, very familiar with. These are some of the things that we're looking at right now for some companies and at Georgia Tech, as well as for the DoD. And as you can see, there's a lot of, obviously, IoT has half a dozen different communication protocols. So you wind up with a series of closed loop networks. How do you get to that information? Within the DoD, there's a whole lot of interest now in terms of how do you share frequencies. The DoD has given that up to commercial interest. And in cases where they can't give it up, then how do you do dynamic sharing? And of course, a host of different peer-to-peer networks. I have whole presentations on what we're doing, for example, with our smart home at the Georgia Tech campus. How do you integrate these tools into the home? But then how do you do, for example, the day in the life of healthcare? So somebody who has their Fitbit, and maybe they're leaving from the smart home that we have, which is networked. They traverse campus, which goes across yet another network. And then finally, they get into a building there on campus, and that has yet another network. But maybe they're also diabetic, so they have an insulin pump. So now you've got two different sets of data going through the same gateway. One of them requires segmentation because of HIPAA requirements. The other one's your personal records. So the security piece of how do you handle that in terms of privilege managements for the right access? Those are some of the tools that we're looking at. And then, of course, plug-and-play sensors, tremendous amount of work going on there, especially on the academic side. As I said, I mostly represent GTRI, which is the not-for-profit applied research arm at Georgia Tech. I am a tech employee, but I don't teach. But we also have the more traditional academic side work that's doing some really cutting-edge things that I think our gentleman from Boeing earlier mentioned some of that work with the Mechanical Engineering School. And then all of that has to drive open standard solutions. You know, again, the data and the network and the information is useless if you can't actually get to it. And I'm going to speed up a bit because, again, some other ongoing IoT challenges that we're working towards is, as many of you are involved with, how do you do a self-establishing, self-healing networks? How do you recognize that that bit of information is out there, it's tied to a network, and you need to get to it? But in order to do that, you have to have security. And if some of you are familiar that working on the security side and have seen things like the Mariah botnet and what happened there, where just devices on somebody's cable modems, chips, and then a few other locations, somebody was able to send a denial service because they still use the manufacturing passwords and actually generate a denial service that took down half the East Coast. And I think it was so successful, the company was concerned about it. So they were a mitigation company for denial service. They offered tools for that. And so they released it to the open market just to show that they were good folks. They're now in jail. But it has now shown up in the Russian mafia and is called the OMG. Oh my God, it's back. That's literally what's happening. So these tools are out there, so we have to start with zero trust first. And how do you handle that part? Those are some of our key points. And of course, scalability, there's always a question about the scalability and what do you do with massive data sets? Our work with the City of Atlanta has already shown that they've collected incredible amounts of data. They have no idea what to do with it. We're trying to help them sort through it. But it's hard to show that a $10 million investment for the city and making streetlights smart, they don't come on when nobody's there at 3 in the morning. But how do you show that that's a measured improvement to the bottom line, it takes years to pay some of that back. So the city is quite concerned, and those are spaces that we're coordinating on. So I want to talk some about the DoD side, because I know that hasn't been brought up here much, but it is as much talk about the federal government and some of the things that they may have. They're far behind all of you. They really are. They're way behind many of you in so many different ways. So I have a project right now with the Marine Corps Logistics Command, and there we're looking at how do you optimize the workflow for the logistics and storage and maintenance. They can't track the tools, the systems and platforms that they have. How can we, the Georgia Tech side, do training and teaching and education for doing some of this? Adaptive manufacturing. You might can imagine some of these systems are now 30 years old. They don't make the tools, the parts anymore. So can we use IoT, realize that that system needs these new parts because maybe it was in an area where heavy operations for a number of years, and 3D print it on site so the maintenance worker can then immediately deploy that, but you know that the quality there is good enough that it's as good as the original OEM if possible. These are the topics that we're currently doing with them right now today. And then autonomous inventory. The way they do the inventory right now is they get 200 Marines and a consulting company and take pad and paper and go around and check where everything is. And they're required to do it every year, so it's incredibly time intensive. So we're developing tools to do autonomous inventory. I saw some folks doing the robots moving around the warehouse, so that's what we're doing right now to get real-time awareness. You currently using RFID tags. The future is actually coming to where you can have smart tags, smart chips that give you localization down to a centimeter level. Those are some of the things that we're pointing towards with them. And then not only that, I'm sure all of you have legacy software modules. When I looked at the Marine Corps, there were about 120 different software modules, some of them that had not been changed in 20 or 30 years, but they're still used. So how can you ensure data interoperability? And then the next generation, which is what I'm very, very interested in, is the AR, VR mixed reality component. How can you actually take the maintenance worker, they know the systems in storage, they can autonomously have a system go, narrow aisle forklift, pick it up, bring it to them, realize too that the specs need to be brought up on a heads-up display. And by the way, if you start with these procedures first, we know this other part's obsolete, but it'll be printed by this afternoon. So it just increases the entire efficiency of the operations. And so those are the programs we're currently conducting. So now what does that mean? It means that it's the holy grail. So Internet of Things, eventually tied into a high-speed network that touts all of the low latency, high bandwidth. My problem is you can't have them all. But that's what it touts right now. So I refer to 5G as not just the cellular access, but more of an ecosystem, because nobody's going to go away from the Wi-Fi 6, how you tie into Zigbee tools, the other platforms. So it's all got to integrate and then share the best of what 5G is supposed to be bringing to the table. And that's the ultimate golden rule, is what I tell people is really what you want. 99.9% of the data out there you don't care about. You want it to happen autonomously. You want it to be there. But you need that one bit of information in the format that you can operate in, wherever you happen to be, and sometimes maybe even before you know you need it. So that's really the ultimate golden capability. So heading to the DoD now. Through the National Spectrum Consortium, and you can look that up, it's all one word, nationalspectrumconsortium.org. Several of your companies are actually members of it. It was created, and there was a presidential memorandum that said, we must ensure America's future for infrastructure and technology. And these come out all the time, but the good thing is we had already created through the DoD something called the National Spectrum Consortium. I'm on their executive committee for that. And the goal is fostering collaboration between government and folks like yourself. And the initial requirement is they're giving up frequencies. Should they move current DoD systems out of that, or are there smart ways to do dynamic sharing? Those were the initial tools. If you fire up a Navy radar, but you've already assigned systems for commercial use in your factories at 1700 megahertz, if that were to happen, you fire up a certain Navy radar, it may knock it out for 150 miles around. So that's just things that happen. So you have to be aware of that, you have to coordinate it. So that was the original vision of why NSC was stood up. However, they've now been tasked, the federal government is very, very concerned about you losing their lead in 5G. And so they are developing a series of use cases. And that's the one use case that I'm going to talk about. But you can see they want to leverage the data, engage with industry, engage with local governments, ensure that it's secure, and they're not trying to create 5G. They're trying to show that there's compelling use cases out there. So just a few more. A little bit out of order. They're going to submit a series of proposals. The first one actually came out yesterday afternoon. The first set of proposals is for about $220 million. And that is to create technologies or demonstrate the use of technologies in a 5G test bed. The Marine Corps folks I'm working with, they got selected, Albany, Georgia, of all places, was selected as one of the first of the 4 5G test beds. And here's their approach. Here's why they're saying that. It's transformational. It's not just new radios. It's not just phones. It's seamless, ubiquitous connectivity. That's what we said IoT would be, and to a degree, it is. But now can you take IoT and create what I've called that ecosystem, and now you have true access to the information wherever you happen to be. And that's critical for the DoD, but as I mentioned, the thing that they are assuming is zero trust. And that's because of things like manufacturing device chips, maintaining the passwords, the original manufacturer passwords, or zombie devices. Somebody's still running, and I've got this at home, somebody's still running maybe some old wireless network gear, it's not patched, and there's no process to even do that anymore. So that's what we call zombie devices. They're still out there, they can be exploited. Not in this slide deck, and some of you may have seen this, but as part of my security presentation is a search on, for example, using the Shodan search engine, where they did a scan. This actually dates back to 2014, so it's a little different now. You might say it's proliferated even more. They did a scan just in Germany and parts of Italy for certain PLCs that were in the energy infrastructure, in the hospitals, et cetera. And in just a few weeks, found, under a project called SHINE, found that there were over 1 million potential PLCs with potential vulnerabilities because they now have public-facing IPs. That's what happens as you evolve IoT. And it's not I'm not saying we don't do it, but you have to be aware of that. And I won't go through the great detail here, but you can understand some of the use. Obviously, there's a major interest in the military uses and the spectrum sharing. But there's also partners with us in this is NTIA through NIST and the Commerce Department. Obviously, the FCC is extremely interested. So we have a number of partners that are very motivated and interested to understand NOAA, how this might impact their systems as 5G evolves and as more people are communicating. So they really, truly want to engage all of the U.S. industry where possible, and there's an international engagement part to it too. So we're already working some collaborations with the UK, and they're working one with Spain. And so there are other areas of interest to say, how does this migrate and support global interoperability and yet maintain security? So some of the experimentation, obviously what they wanted to do was not drive 5G development, but drive the usage of 5G and show that it benefits by being able to do so. And some of these things I've already talked about, so I'll just jump to the next one. The first set of experiments, that's what I described. There's one at Hill Air Force Base where it's dynamic spectrum sharing. That's one of the locations where you turn on a radar and you happen to be operating on what some of you may be familiar with, the CBRS band. That's a huge political football right now, but opening up 3, 4 to, it depends on what you call it. It's eventually going to be 3 gigahertz to 4 gigahertz and even higher. So that's still in discussion. But if you do that, there's a lot of radar systems at these Air Force bases that operate at 3.5. So you don't do the mistake that I had accidentally one time where I fired up a new 3.65 gigahertz unlicensed system and knock National Public Radio off the air. So you don't want to do things like that. But the reason is they had a very old system where the bandwidth was still wide open, 3.6 to 4. They were supposed to have upgraded it so it was narrower. We happily turned on our system, and about 30 minutes later, the guy came running across. We share a parking deck. Came running across to us and said, "Hey, we saw you on the roof. Whatever you did, turn it off." And that's just an example. Nobody did anything wrong, but they didn't understand what was already out there. And that's some of the examples of what the DoD, the government, and I think industry should be very motivated to try to solve. So the other ones are AR/VR, and that's, again, where I think is so much of the world is headed. Can you use 5G for AR/VR? Obviously, the latencies and the speeds, data rates are incredibly important for that. And then there's two others. So the one with San Diego Naval Base happening right here, and then the other one with Marine Corps Logistics Command. Just a little bit more detail, but it shows some of the things I talked about. How do you digitize, automate, and optimize the warehouse? As I mentioned, right now, they are just putting Wi-Fi in the warehouse. They have nothing else. So this is a great leap in technology to integrate the sensors, integrate RFID tags and other sensors, and get that information in real time, make it autonomous, and add the AR/VR. That's the one in San Diego, almost identical. That's the one in Albany, Georgia. You'll actually see that's a little robot that we built to run around under large wheeled systems, and it reads the RFID tags, it localizes. If it doesn't see what was there yesterday, it'll actually notify them that, hey, this one's missing. But it snaps pictures of the equipment too. It's actually snapping a picture underneath the carriage. So it stores all that into their system so they can understand not just the location, but the health status of the equipment. Are they ready? That's what's one of the key things. They have to know, are they ready for whatever might be coming their way? And 5G outcomes, we've talked a little bit about that, but they want to improve facility operations, tactical operations. Can you pick this up and go to a forward base and operate in the same fashion that you operated in the U.S.? That's critical. So, you have to operate the way you train, or you should operate the way you train. And of course, there's critical concerns around how people might exploit that, and that's the security component. They aren't doing it in a vacuum. They're engaging quite a bit with standards. And so that includes 3GPP, IEEE. We just presented a major conference, IEEE, back a few months ago. And the whole concept is integrate it with the releases that are happening with 3GPP and the IEEE and some of those standards approaches. That's just another snapshot. It just shows you the 4 technical categories that they're breaking the project down into. And they're ones that many of you are familiar with now. So if you're working technology or tools or implementations in the warehouse, these are some of the questions that you come across, I'm sure, every single day. And that's specifically the breakdown of the one here in San Diego. But it's like you might expect: 5G infrastructure, the network enhancements, and then the utilizations, the experiments. So, just to wrap up, it's not a technical deep dive. I can go off on sidebars, and we can have that if you'd like, but I wanted to give an overview of what I think is a key important program for the U.S., but also for international collaboration. So Georgia Tech, we're working on IoT systems deployments with a host of different test beds and smart city, smart base. 5G is that kind of holy grail of Internet of Things to 5G to data analytics and machine learning. That's what we would call the holy grail right now. And the targeted use cases for the federal government in this case is spectrum sharing, integration of sensors. We haven't even talked edge computing, but that's a huge question. That's one of the benefits and one of the shortfalls. If you can't do the edge computing, you lose a lot of the benefits of 5G. So how do you do that edge processing? And then the range of applications. So by saying all that, if you want information through NSC or some of the work we're doing at Georgia Tech with Sedate, or even check and see if your companies are involved in some of those, let me know, because we'd love to collaborate. And with that, that's actually our new building down at Georgia Tech. You're welcome to come anytime. Some of us may not be traveling much over the next few weeks, I'm sure, but that's where we house our Internet of Things Center right now, is down at Georgia Tech, right in the middle of Atlanta.